Hello guys, welcome to Boxing Board. The problem that we are going to see today is Geek hates too many ones. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe my channel Boxing Code so that you never miss out on updates. So let's get started. Here's the problem statement. I want you guys to don't skip this part because the problem statement is something which is tricky. So it says that given a non-negative integer n, you are allowed to make set bit unset. So this is the operation that we can perform, and you have to find the maximum possible value of query so that after performing the given operations, no three consecutive bits of the integer query are set bits. Okay, we are also given one example here, but let me explain some other examples. So what I'm going to do is I'm going to explain one example. So let's take n equals to n equals to 7. So for this 7, if I write the binary representation of this 7, I'm going to have 0 0 0 1 1 1. Now I'm also going to write the operation that we are allowed to perform. So operation is make bit unset. Okay, so obviously when we have some set bit, then only we are going to make it unset. Now what we are going to have is we have this binary representation, and here you can see that at this part you can see I'm having three consecutive bits, but this is something that we should not have because the problem says that no three consecutive bits should be there in the integer query. So what is this integer query? I will tell you. First let me explain you that here we have three consecutive bits and we don't want these. So what we can do is we can either make this bit as unset, either this bit as unset, or I can make either this bit as unset. So let me write all the possibilities. So I have 0 0 0 and 0 1 1. This is first bit is unset. The second is 0 0 0 1 0 1. Now second bit is unset. After that I have 0 0 0 1 1 0. The third bit is something which is unset. If I convert this number into the decimal form, then I will get 3 for this, 5 for this, and 6 for this. Out of all these numbers, the maximum number that I have is 6. So I'm going to return 6 as my output. Now why 6? Why the maximum number? Because the problem is asking us to return the maximum number. So that's why I'm choosing the maximum number. And now maximum possible value of query. So now you can notice this is something which is our query. Query means modified version of this binary representation which doesn't contain any three consecutive set bits. Okay, now I hope you guys are aware, I hope you guys understood the problem clearly, and let me just now explain this example as well. It says that we have n equals to 2. So what I'm going to write is I'm going to write the binary representation 0 0 0 1 0. Now here you can see that there is no any point where we have three consecutive set bits. So that's why I'm going to return the same number which is 2 as my output. So this is going to be my output. I hope you guys have understood the problem, and now I'm going to move to the solution part. Okay, so in order to explain the solution, first I'm going to write an integer array which is a binary array. So let me write 1 0 1 1 1 1 0 1 1 1 0 1 1 1 1 1 1 1 0. Okay, now I have this array. This is obviously the binary representation of any number. So binary representation of a number. Now what I'm going to do is I'm going to check for every window of size k. This is size 3. So I'm going to check each consecutive three bits whether they are set or not. So are these set? No. Are these bits set? No. Are these bit set? These are set. So what to do now? Since I have 3 bit as set, so what I'm going to do is I'm going to make one of those set bits as unset. From here if you notice, from here if you notice that when we made our last bit or the rightmost bit as unset, then we got the maximum number. So is it the case always? Let's check whether this is the case always or not. So what I'm going to do is I have 1 1 1, and now I'm going to give the intuition like If I write this number into decimal form, so I will convert by doing something like this: 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2. So these are the factors which are going to multiply by these bits in order to convert them into binary. So can I say that 2 raised to the power 0 is something which is contributing to this bit, and 2 raised to the power 1 is something which is contributing to this bit, and 2 raised to the power 2 is something which is contributing to this bit, and all these are finally giving me the number by adding up. So what I'm going to do is, I can notice one thing, that the rightmost value is always smaller because the value is increasing. First I have 0, then I have 1, then I have 2. So the value is increasing. We move from right to left. So if you move from left to right, then value is going to be decreased. So if I want to make any bit unset and have the maximum value, so I will remove the contribution made by this, because this is making the least contribution. So I can write that least contribution least contribution is made by this bit. So I'm going to if I remove the contribution made by this bit, then I'm going to have a maximum number. So the observation that I have made is, always make always make rightmost bit as 0, bit like unset, in order to have the maximum number, uh, in order to have max number. Okay, so this is the observation that we have made, and I want you to note this observation somewhere, because this is going to be used in the problem. Now let's move to the problem back again. So if I write the steps to solve this problem, so steps are going to be, okay, I want you to observe the step from here. What we were doing, we were doing first converting the number into binary representation. After that, for the binary representation, we are checking for each consecutive 3 bits whether they are set or not. If they are set, then make the rightmost 0, and else just move forward. And at last, just convert the number into uh, decimal form. Okay, let me write the steps here. So first is store binary representation. Binary representation. The second step is uh, check for every 3 consecutive bits whether they are set or not, and if set, then make rightmost 0. Isn't it? Rightmost 0 or unset both means the same. And the last step is something which is going to be convert into decimal. So if you are someone who know that how to convert a number into binary representation and how to convert to decimal, so you can move to the main logic part. But I want you to don't skip, because I recommend you to watch this part as well, because you may have you may know some other method, and it may possible that I'm giving some other method. So I want you to watch the full video. Now I'm going to explain the first step. So let me explain the first step. And okay, my screen is not working. Let me open it again. So okay, now what I'm going to do is, I'm going to start the step 1. So step 1 says that store the binary form. But how to do it? We are going to do it, first of all, we are given an integer as our input. So an integer is something which can be represented by 32 bits most, because 2 raised to the power 31 is something which is integer dot max value. So max value is something which is 2 raised to the power 31. So at most I'm going to have 32 bits. in 32 bits I can represent every possible integer. So what I'm going to do is I'm going to have an array of 32 size. After that, what I'm going to do is if I have a number like if I have number 1011111000 and I'm at this particular bit. So how to check whether this bit is set or not? How to check? How to check? So the operation that I will do is I will traverse from like I equals to 0 to I smaller than. Okay, I will actually. Okay, I'm going to traverse from I equals to 0 to I smaller than 32 and I plus plus. After that, what I'm going to do is I'm going to check whether my ith bit is set or not. So ith bit is actually from the behind for a number. Like if I have number like 7, so for the first bit, the first bit will be the 1, the second bit 1, the third bit 1, and rest all 0. So we always start from behind. And now in order to check the ith bit, what I'm going to do is I'm going to have a number like which is 0001. This is the binary representation of 1, and now I'm going to left shift this 1 by I. So if I left shift this 1 by I, so I will get like 100000000. Now 1 is something which is left shifted by I and it is at this index. So I'm going to perform the AND between these two. So first of all I'm going to write 1 left shift by I, and even let me use some other color. So I will write 1 left shift by I. This is going to give me this number. After that, if I perform the AND between these two numbers, so all will become 0 and only the number like this one will is going to become either 0 or 1. So if this bit is 0, then it will become 0, and if this bit is 1, then it will become 1. So I'm going to perform AND with the number that I have, and if this is something which is greater than 0, then I will have 1 as my set bit, and if this is not, then I will have 0 as my set. So I'm going to store it into a variable bit. So I have a bit. Now I'm going to store this bit in array. So as I said, we used to always start from 0, so I will store at the last index. I will start storing from last index. So I'm going to have index equals to 31, and I'm going to write array of index equals to bit, and then I'm going to do index minus minus. Now this is the first step. I'm done with the first step, and now I will surely have in the step 2 I have an array which is 1 0 1 1 1 1 1 0 1 1 1 Okay, so this is the array which we are going to take, and now in this array I'm going to check every 3 consecutive bits. How to check? What I'm going to have is I'm going to maintain a sum. So like if I have sum for this 3 consecutive bits, or I will say window of size 3, I have the sum as 2. After that I'm going to shift my window. So here I have the sum again 2, and how to calculate the sum of every window? Like I'm going to subtract this value and I'm simply going to add this value. This is how I'm going to calculate. After that, when I move my this something which is I, this is j, and when I move my I and j, now I has become this and j is this. And how to calculate the sum of particular window? Sum of particular window is sum plus equal to bits. This is array bits of j, and sum minus equals to bits of I, isn't it? See here, I have I here, so I'm going to remove this and I'm going to add this. So this is how to like get this window. After that, if I remove this, if I add this, so I will get this window. After that, if I remove this, if I add this, I will get this window. So this is how we are going to get the sum for every window. For the first window, we need to calculate it manually. Okay, now what I'm going to do is I'm going to check if my sum equals to 3. For any window, if my sum is equal to 3, then I will surely have 3 consecutive set bits, because there is no other possible way that we can have sum 3, because I have only either value 0 or value 1. So this is a binary array, and only possibility for sum equals to 3 is we have 3 set bits. Now when we have sum equals to 3, then what we are going to do is we are simply going to check we are simply going to make the rightmost bit 0, because this is the condition how we are going to check make rightmost bit 0, which is bits of j. Bits of every point, my j is here, which is representing the rightmost bit, and I is here, which is representing the leftmost bit. So I'm going to make my bit of j equals to 0 every time. So this is what we are simply going to do if I write the pseudocode. So I'm having I equals to like I equals to 0, j equals to 0, and after that what I'm going to do is I'm going to move my j for the first window. Like if j is smaller than 2, then I'm simply going to add bit of j, and else what I'm going to do is I don't have I have reached the index of my first window like 0, 1, 2, 3, 4. So like 2, 3, 4. So this is the second index, and now I have my window. So else what I'm going to do is I'm going to first add this value because I have not added this value. So add bit of j, bits of j. After that, what I'm going to do is I'm going to check if my sum double equals to 3. If my sum double equals to 3, then I have to perform some operation which is bits of j equals to 0. So this is just the pseudocode. And after that, in order to have the sum of current window, what I'm going to do is I'm going to remove the particular value which is the sum of like I. So bits of I I'm going to subtract. So I'm going to subtract bits of I. So and after that we are going to do I plus plus and j plus plus, and here I will have to do j plus plus. So this is what I'm going to do till while my j is smaller than 32, because 32 is the maximum index that we have. And you can see that this is the operation that we are performing at this point. Now this is the step 2 that we have performed, and now I will surely have my modified array. So let me move to the step 3. In the step 3, what I'm going to do is I'm going to convert to decimal. How to convert to decimal? In order to convert to decimal, if I have like an array like 1001, like 101 101, okay, I have this number. So I have already told you this is 2 raised to the power 0, this is 2 raised to the power 1, 2 raised to the power 2, and so on. So how I'm going to do, for each like value I, I'm going to traverse from back, traverse from back. And now what I'm going to do is I'm for each current bit, if it is 1, then I'm going to add 2 raised to the power I. So if bits of I double equals to 1, then like what I'm going to do, I'm going to answer plus equals to 2 raised to the power I. This is what I'm going to do, and at last I will surely have my number in my answer variable. So return answer. This is how we are going to solve this problem. I have already explained you 3 steps to solve this problem, and now let me just move to the coding. So this is the problem, and now I'm going to show you the code for this problem. I have already copied the code because live coding is something which is going to take a lot of time. So let me paste the code. Okay, so this is the code that we have. Now you can see that first we are storing the number in the same way that I have told you, like we are calculating the current bit, and then we are storing in the bits array. So this is storing number. After that our main logic start from I equals to 0 and j equals to 0, and we have sum equals to 0. So for the first window, I am simply going to add j, and now I have my first window here. So first I will check at the current bit, and I will check whether my sum is equal to 3 or not, because if sum is equal to 3, then I'm surely having like my current window as having all the 3 bit set. So in that case I'm going to make the rightmost bit 0. I also have to do this operation because this is something which is going to make remove the current jth bit from the sum as well. Okay, because we have already added that here. And now at last, in the last step, I'm simply going to convert the number into binary form. So this is about the problem. I hope you guys like the video. So if you like the video, then hit the like button. Thank you.